Okay, right, so the strategy is to use the word rucksack. R-U-C-S-A-C. And it stands for read. Read the question. And when you're reading the question, U is underline any key information that you think might be helpful when you're doing a calculation. C stands for convert. So you're looking for anything that's not in standard units that you would expect to use during a calculation. S stands for substitute. That's where your first mark comes from in any calculation question. A stands for answer, and then C is check that your answer you've got seems reasonable. So let's have a go. We read the first question. Calculate the period of time, there's a factor, let's underline that, in seconds, during which the 600 joules, so we underline that. Joules is our measurement of energy, so we'll make a note that we know that 600 relates to the quantity of energy. So during which the 600 joules of energy is provided to the 30 watt light bulb. And again, like we did before, we know watt is a measurement for power, so we're going to write that there. Now we're looking for time, so you need to have learned the calculation that links energy, power and time. It's quite a common one, so if you are going to learn some, this is one's really, really important. So we write down the calculation that we've learned, which says energy equals power times time. Convert. Now I'm checking for conversions. I've got energy in joules, power in watts. I'm happy that I've got units that are used in calculation, so I don't actually need to do any conversions at this stage. So I move to S, substitute the numbers in. Energy. So I look back at what I've underlined and I've got 600 joules of energy. Power was 30 and time is what we're trying to calculate. So I've now got my first mark for substituting the numbers in the right place. So even if I can't rearrange it, to get the final answer, I've got 1 out of the 2 marks. Think back to maths. How do I change the subject of the equation? So I'm going to divide each side by 30 to be able to get A, my answer. So I'm going to do 600 divided by 30 equals 30 divided by 30 times time. That cancels out. 600 divided by 30 gives me 20 seconds. I'm going to check my answer. 20 seconds, that's a reasonable amount of time to transfer that amount of energy. Question 4 on the calculations that I gave you, if we jump straight down here, seem quite difficult because it says to calculate, but we're not actually given any numbers. So the first thing we've got to do is go back to our substituting and read the question. When a mains lamp is switched on, it takes 0.5 seconds. It might be useful, we're not sure yet, but we'll underline it could be, for the filament to reach its normal operating temperature. So that's telling us that when we switch a lamp on, it takes half a second to get to its normal operating temperature. The way in which the current changes during the first second after switching on is shown in the graph. Mains voltage is 240 volts. So let's look at what we've underlined. We've underlined 0.5 seconds, which is time. We've underlined 240 volts, which is voltage. Then we'll look at the graph. Let's see if there's any useful information in there. Current. So that's another factor that we've got here, which is current. And we've got a peak on the graph at 0.4 amps. And then it going to standard conditions. Let's assume this is our normal operating temperature, the thing we underline in the question, at 0.2 amps. So let's go to the question. Calculate the maximum power taken by the lamp. Maximum is where we have a peak in the graph. We noticed when we looked at our graph that our peak is at 0.4. So we know our current at the peak is 0.4 amps. I've learnt my formulas. Again, another fairly common one. Power equals current times by voltage. You might see voltage sometimes written as potential difference. So I'll go back up here, convert my units. I've got voltage in volts, happy. Current in amps, I'm happy, so I've no conversions to do. I want to substitute my numbers in. Power equals current, which was 0.4, times by the voltage. Now remember that it's right at the top of the question, and it was 240 volts. Nothing too difficult this time. I multiply my two numbers together, give me 96, and we know power is measured in watts. We then go to the next question. We can't really check that number. It looks reasonable, but we've nothing to measure it against for now. Calculate the power of the lamp in normal use. Now, normal use, we said, was after 0.5 seconds, the information we had in the question. And we recognised at that time, where time was 0.5, after that, current is 0.2. So we'll make a note that from our graph, current is 0.2. You can see why this is a little bit trickier, because I'm having to extract information from lots of different places to be able to do the calculations. It's the same calculation we had before. Power is current multiplied by voltage. Power equals, convert, nothing to convert. I'm in my standard units, so I'm going to substitute my numbers in. 0.2 times 240 volts. Find my answer, 48 watts. Check my answer. Now I can check this one. When it was in normal use, it's going to be less. Numbers are less, that's okay. It's going to be less than it was at the maximum, and it is. I've halved my current and I've halved my power. So it looks like a reasonable answer, so I'm happy that I've got that one right. Calculate the energy used by the lamp in 6 normal hours of use. So we're going to use our strategy again. Calculate the energy used by the lamp in 6 hours of normal use. So we know from normal use that our current was 0.2. We don't know if it'll be useful yet, but we'll see. 6 hours. So we're going down here. We've underlined. We're now up to convert. We know 6 hours is something we've got to change. We've got to change 6 hours into seconds. Now, to get from hours into seconds, we've got to multiply it by 60 once to get it into minutes. We've then got to multiply it by 60 again to get it into seconds. When I put that in my calculator, I end up with 21,600 seconds. Big number, but that's about right. There's a lot of seconds in 6 hours. Calculate the energy used. We used our energy calculation earlier on at the beginning. As we said, it's very common. So we write down that energy equals power times time. Power. Now, I've no power in here either, but I have got normal use. And I worked out the power in normal use in my last question. So when I'm substituting in this time, I'm going to use the number that I've calculated in the previous question. I'm going to use 48 watts because that's our calculated power in normal use. I'm going to multiply that by the time that we've converted, and I end up with a calculation here. Work out the answer, and it gives me 1036800, and we put joules on the end. Checking our answer this time, does it look reasonable? Well, it's a really big number, and energies are very often really big numbers when we work them out when we're using time in seconds. So I'm happy that that is a correct answer. So there you go. That's a way of answering your physics questions using the strategy of rucksack to check that you're picking up all the marks, checking your conversions. Substituting will always get you your first mark, even if you then can't do the multi-steps that come after it. Good luck, Year 9. Well done, and keep trying hard.